Loaded.
Well, why?
Yes, for me it's the same. I too cannot download. I'm trying to download it.
Uh-huh. If it doesn't work, then I will email you. Okay, just a moment. I will email you.
Yes, please. Thank you. Because it's not getting downloaded.
Okay. I don't know why. Okay, I will email you. Just a moment. Okay, open. Yes, I emailed. Check your email. Okay, let's see. I mentioned last week we will do a regression analysis. This regression analysis is also one of the important part in statistics for analyze data. Also, I covered this part in the class. So you may know what is the regression analysis, but then for this class, using R, not Excel. So as you know, regression analysis find the relationship between X and Y variables. X variable usually we call a predictor, and then Y variable is like output, maybe response, and so on. So enables you to develop a model using a regression analysis. Then we can use that regression equation for a prediction and getting insight and so on. And then if we have only one predictor X variable, we call simple regression. And then several predictors, then several multiple X variables, then we call multiple regression. Like last time, we can use this R commander to do this regression analysis. So let's open R and RStudio. Then we do this one again. Install packages, R commander, and then execute using library. So do it again like last time. So let's do. I found that, make it this pane larger using this view, and then zoom in. Then I made it bigger, so it's better to look at. So install packages, and now we need an R commander, and then wait. The day before yesterday, my son complained about the internet speed. So I researched what internet service provider available in my town. Then one company, based on their advertisement, Fios using fiber optic, then the speed is very fast. So I called the company and then try to order the faster internet service. Then I ordered, they call a premium internet service. Then the speed up to 100 mega. So after I ordered, next morning, yesterday, I checked email, the order confirmation. Then they put in my order as they call prepared internet service. The speed is only 18 mega. Currently, we have a 40 mega service from other company. So I call the company again, and then I canceled that my order. And then I call to my current internet service provider, and upgrade to 100 mega service. So now my internet is faster than earlier. Okay, and execute library rcmdr, and then R commander here. So we'll make it bigger. So do you have this R commander? Are you ready? When you are ready, let me know.
Just a second, Dr. Kim.
Okay, I can wait. Winter night is long. The summer night is short, but the winter night is long. You know, I checked internet speed, my internet speed. Now only 34. Because this time many, maybe my son used internet too, so slow than earlier. Earlier my speed was like 100 something. Check again. Yeah. That is enough for me. Fast enough. Okay. Now, ready or not, here I come.
Dr. Kim.
Yes.
My R Commander, like the new window, did not pop up after I entered library.
After enter everything, then it's not pop up, but then under the menu here, taskbar.
Oh, let me see.
If there is another R logo.
I used to have that logo.
So this one is, you know, the R, and then this one is RStudio, and then this one is R Commander.
R Commander. Okay. Let me see
So
if I can
click
get
this one, and then this one here.
Okay.
Now Alia is like my teaching assistant. Kenny, are you okay? Okay.
I'm doing better, sir.
Okay. How about Lizeth?
Yes, sir. I'm doing fine. I'm good.
Okay. How about Sujal?
Good, good.
Okay. Okay, next, we need the data. So click data. Then import data, move your cursor. So depending on what type of data set, you can choose an Excel file, any file. But then I sent to you or the available file on the Google. That is not text data. The extension is DAT, so text data. So we will use this one to import the data. So click text file, then data set, and then from a local system and so on, then okay. Then wherever you download the file, find the directory, and then import this album sales 1 DAT. So click this one, highlight, and then open. Then means import the data set. What the session aborted? Start new session. Something wrong. Okay. Mine. Do it again. Install. No. Data, import data from a text file. Okay. And album sales, one data. Okay, good. Okay, and then go back to slide. After input data, linear regression in statistics, fit data, fit models, and then linear regression. Then after that, we should specify what is y and x variable. So let's go. So statistics, fit models, linear regression. And then here, response variable. This is now y variable. And then here, explanatory. This one is predictor, x variable. So y variable is sales. X variable is advertisement. And click OK. So this R commander is kind of like an execution tool. Then the results in RStudio. So in RStudio, the result of that linear regression kind of output here. Do you have this output? Okay, then the output looks like this. So using this output, we can develop linear equation. So intercept and then x variable coefficient here. So we can use this one, R commander, do regression analysis, and then go back to our commander. Then like in last week, we drew a graph using this R commander. So we can use this one, scatter plot. And the same, y is sales, x, this one is x is advertisement, and then sales, y, and okay, then we can develop the chart like this. So looks like the direction is like this, positive, then somewhat scattered. So I can expect R score correlation is not very high between x and y variable, but anyway positive. So we can read here. Coefficient of the x variable is not much, but positive. And then here, R squared 0.3346. I will talk about this one later. Okay. Now we will use regular RStudio, do the regression analysis using R. Then we need a package like this. Let's do. So install a package of car, then execute this package. Then this one is kind of stat package. So without install the package, just execute. Then we need quant this package for other function. So let's do install and then execute. I will do together. Now we will use our commander, maybe later. So now install package car um, site. I'm done.
Dr. Kim,
Yes.
Alia's R session is still restarting.
Okay.
So we don't know if it's the internet or if it's just the program
Maybe.
or because she has a Dell.
Her computer is not there. So I can wait. And you may catch up later because you know what, same thing we do again and again. So it is okay. In my home, 1, 2, 3, 4. There are 4 desktop computers, and then 1, 2, 3, 4, 5 laptops. Then 1 Chromebook. But then the new one now I'm using, and then others still work, but a little bit slow. So last night I reset two laptop computers at the old one. I tested if I make it faster, and I may need like an upgrade RAM, maybe upgrade CPU. Then it costs. So I don't need. I don't want to spend more money because now I have a new computer fast enough. But in case like a backup computer. Okay. After you install packages and execute, and we can go next step. So in this RStudio, bring data. You know, last time, until last time, I used read CVS function. That case, if we convert Excel file to a CSV file, then bring import CSV file. That case, we use read.csv. But this time, we just without convert this text data, just bring this text data. So using delimited data, so bring delimited text data. So using this function, and then others are the same. And by the way, we may not need this syntax header equal true, but sometimes without this one, we don't have a header, like a variable name. So just in case, included this syntax. So it's like that. So I will import the data. So the data set name I named album 1 data set. Put by this one read that delimited data set, and then the data set name is album sales 1. By the way, you need this one, you know, make a project and then bring the data here. You know how to do it, right? Okay, before that, before we go, I will, I already done, but then in case, I will do it again. A new project, I don't need, then existing, then find wherever your data set is. So mine is in chapter 7, data, open, and create project. Then you can get data like this. So you need a project to bring the data, create a project. Lijes,
Yes, sir.
can you do it?
Yeah, I'm doing
Okay,
fine.
okay. And then after you bring data, whatever you need here, and then use this album and whatever you like, make a name. But I named like this: album 1 data set. Then put with that delimited data, and the data set name is this one: album sales 1. .dat, and then header equals true, and then check if we bring or the data right. So data set looks like this. So first column, advert. I think this one is an advertisement. Advertisement like a cost, expense, and then sales. The data set, the sample size is 200. So after that, if you import data, then we can use LM, linear model, LM, then make like a table. This one is like a make a table using LM, linear regression model. Then sales, y variable, and then x variable. So outcome, y variable, predictor, x variable. Then data equals album 1. And then this function, not available action, in case if the data not match, then exclude. So type this. So I will do the table name is linear model 1. Put something there using linear model function, and sales is a y variable, and then other but those are not, you know what, column name or a variable name. So a y variable name and x variable name here. It should match like this: sales, advert, and then data equals what data we will use: album 1 data, then not available action equals not available, exclude. Oops, I don't need that. And enter. Because we made a table using linear regression, so there is no result. But using summary function, so summary is in a table, and you can see the result. This result the same as using R commander. So coefficient here, intercept is 1.341 times now 100. So this one is 134. And then minus 0.2, that means divided by 100. So it is 0.0961. So it looks like this. So using this, let me use. After you get the result output, then we can okay. So from this result, can develop equation, as you know. So this one intercept. So equation will be y. Oops. Why is not working good? Just a moment. Set up this one. It's okay. Y equals intercept. This one is 134.1 plus 0.09612 x. So from this output, we can develop equation like this. Okay. So developing this equation is important, but we test if we develop right good equation. So overall test, overall fit of the model. From the output here, multiple R square, that is 0.03346. So that is an R square. That means X variable advertisement can explain about 33% of the sales. Y variable. Then using this function, square root. So square root of an R square will be R. So we can use the R, then like a square root of 0.3346. Then this is R score. So R score is 0.578. Not very high, but about there is like a relationship, not strong, but some positive relationship between advertisement and the sales. And then when we do this in a research methodology, then I used F-test. So for this result here, F statistics is 99.59, but we don't know critical value from here, but we can use this p-value. If p-value is less than alpha significance level, if we use alpha is 0.01 or 0.05, whatever, this one p-value is very small, almost zero. 0.00016 times and then 2.2. So very small. So p-value is less than alpha, whatever. So this regression model is a fit. That means this regression model is developed well. Significantly, this regression equation work. So to predict sales using advertisement expense, that work. This is an overall fit of the model. So using R, we can see approximately, and then we can determine if this one works statistically using p-value. So p-value is way less than alpha, whatever alpha is 0.01 or 0.05. Okay. Then multiple regression, oops, mistype, regression, mistype here. Multiple regression using R commander. Let me fix that. Is it right? Just using R commander, multiple regression. We need another data set. Let's take a 5-minute break and then continue multiple regression. Now 7:50, so I will be back at 7:55. Okay, I'm back. So open R commander. And we need another data. So import another data, import data, the same. So now we will use this now. Album sales 2 data. Open this data set. Then we specify X and Y variables. Looks like this. So this time, multiple X variables. Y variable is always one variable. So in our commander, the same statistic, fit models, and linear regression. Then here, Y variable is sales, and then X variable is data, advertisement, airplay, and attract, 3 X variables. So I will use the shift key and then scroll down, or you may use the control key and then one by one. So specify Y variable and then X variables and then click OK. Then on the RStudio pane result. So results, the output looks like this. Similar to a simple regression, but this one multiple, because this one is a multiple regression. So there are 3 X variables. Then the same multiple R sphere and F statistic and so on. Then we can use regular R. So we need another data set. So the same with delimited data. The data set name is this one. So using the same function, make a data set like this. Let's see. Oops. Okay, change. Bring, import data set name, album 2. And album 2, the data set looks like this. So there are actually four columns or variables. Sales is Y variable, and then other, advertise, airplay, and attract. They are X variables. And then using a function, LM function, we can do like this. So I will make a table using a linear model function. Then Y variable is sales, and then X variable will be advertisement, airplay, attract, and then data from this album 2. Then if there is not available, then exclude. Type. I will make a table model 2 using LM function. Then sales is Y variable. Then X variable will be advertise plus airplay plus direct to, and then data set will be album 2. And then not available action will be not available, exclude. What the? Album. What's problem? Mistype. ERT. Play. Play. What the? No parentheses. Okay. And then summary. Model 2 done. So this output similar to the output of no. Our commander. Okay, so looks like this. This output. And then using this output, we can test global bit test, the same. R square from the output here, 0.6647. Then using square root function, then we can get R, 0.81. High relationship, correlation between X and Y variables. So it looks like this we develop good equation. By the way, we can develop equation using this output. Looks like where is so y equals intercept negative 26.61 plus 0.084 x1 plus 3.367 x2 plus 11.086 x3. So x1 is advertisement variable, x2 is airplay, and then x3 is attract. Airplay. I just airplay. What is that? You know, we have one small air fry. Then recently, last Black Friday, I bought the bigger one, air fryer. So air fry. Anyway, so using this output, and then F statistic is 129.5. But even we don't know what is F statistical critical value. But anyway, p-value is very small. So p-value is less than whatever 0.01 alpha or 0.05 alpha. So this model is significant, so developed well. And next one, you know, individual test. Overall, by overall fit test, we determine this equation work, but we don't know which variable work or not. So test individually. From the that output, this part, for individual test, each variable t-test, two-tail t-test, we may use this function to get critical value. You know, t distribution similar to normal distribution. For this individual test, t-test and two-tail test. So if we use 0.95 confidence level or alpha equals 0.05, then we can use this function, find the t distribution, t value, qt, and then alpha divided by 2, or 1 minus alpha divided by 2. Because alpha is 0.05, then this area is divided by 2. So 1 minus 0.05 divided by 2, that is 0.975. So using this, and then degree of freedom is here. Go back to just a moment. The output here, 196. Using 196 degree of freedom, and then we can find. So go back to RStudio. Then Qt, .975, and then degree of freedom is 196. Then critical value is plus minus 1.97. If we want to find one tail, then just use 0.95. Then 196. Okay. So if it is only one tail, left tail, then negative 1.65. If it is now a right tail, then positive 1.65. For individual tests, two-tail test, the critical value is plus minus 1.972. So t-value is here. For advertisement variable, t-test statistic is now 12.261. Outside, this one outside, this one also outside. So they all are significant. So and then we can use the p-value. They are smaller than alpha. So all variables are significant to predict sales. So we can say the advertising budget is significant to predict the sales, then predict airplay, and then attractiveness also. So using this individual test, we can determine all variables, predictors are significant to predict the sales Y variable. You know, like data analytics, business analytics, using data, analyze, and then from that analysis, we get insight. And then using that insight, support decision making. Okay, we can develop equation from output, and then using that equation, predict. But we don't know each variable, how much they affect. We can use standardized beta estimation. Usually we can denote like this, beta I 1 to 3, if there are 3 variables. So using this function, make some output like this. We need standard deviation for each variable. So make a standard deviation table output like this using this function. And then after that, using this function, then we can get standardized beta. Better than we can get insight like this. Let's do it. We need a standard deviation for each variable. So using this function, SAPPLY, apply, standard deviation apply, and then using album to data set, and then make a table from 1 to 4, because there are 4 variables. So 1 to 4. We may type each variable name one by one, but we can use from variable 1 to 4 variable. Then we need standard deviation 10. So standard deviation of advertisement, sales, airplay, and attract. And then we need a better standardized beta using this linear regression. Where is that? Oops. LM. Maybe it doesn't work. We need an what is that? I need an package again. The package is this one. So install the package again. Okay, LM work. So using LM beta, to use this function, we need this package. We did this one earlier, but it didn't work. So I install this package again and then execute. So after we get that output, then we can interpret like this. Here, advertisement standard deviation, sales standard deviation, airplay standard deviation, attract standard deviation. Then here, standardized beta for each variable. Here, advertising budget. From this output, we can say like this: if advertising budget increase by 1 standard deviation, the advertisement increase. This one is actually thousands, so 485,000 standard deviation dollars increase. Then 0.511 standard deviation increase of standard deviation of sales. 1 standard deviation of sales is $80,000. So increase this much sales. If 1 standard deviation of advertisement expense increase, then 1 standard deviation of sales times this standardized beta increase. So increase $485,000 advertisement increase, then sales increased by this 0.511 times 80,699 sales. Then airplay, radio plays the song, the album, 12.27, 1 standard deviation of airplay times in the week before release that album. Then standard deviation of sales times 0.125 airplay 12 times standard deviation of sales increase. So anyway, this one is 80,699 is not a dollar. It is the number of albums. And then attractiveness, a band rated 1 standard deviation increase 1.4, about 1.4 increase. Then sales increased by 15,490. That is 1.92 attractive. 1.9 actually 1.39 attract. Yeah, here 1.91 approximately 0.192 times 1 standard deviation of sales increase. So this, standardized beta estimation is useful for the decision making. If a company has data like this, then which factor affect about the sales? So using this beta, we can make a decision which marketing decision, sales decision use. So from this insight, we can get kind of recommendation for decision making. Okay, I think that's all for tonight. I prepared. Okay. Okay. Stop recording. Where's record?